everyone, I'm Teacher Im. For those who are new here, I create videos to help my students score better in their Stpm Sem 2 paper. I hope this video will be helpful for you too. Today we are going to talk about differentiation of implicit functions. There are two types of functions here. The first one, the explicit functions, which are functions that can be expressed as an equation in terms of one variable. We have been using that for many times. For example, we have y equals to 2x cubed plus 3x squared minus 2x plus 7. For this type of equation, we can easily differentiate them, because when we differentiate in terms of x, the variables agrees. So we can just simply differentiate it by using either our power rule, our product rule, or our quotient rules, or any other differentiation rules. Implicit functions, in the other hand, are implied by an equation. You cannot separate the variables and express y in terms of x. For example, you have 2y equals to 2y cubed x cubed plus 3x squared minus 2yx plus 7. When we want to differentiate them, you will notice when we differentiate in terms of x, there are terms that does not agree with that differentiation. So in this type of case, we need to use implicit differentiation. To do implicit differentiation, it is very important to remember that every time when we differentiate y in terms of x, we add dy dx to beside the terms. Now, bear with me. These are very important and simple things to remember. When we differentiate y, we get equals to 8, we get 0. So when we differentiate y, we actually get dy dx. Differentiate 8, we get 0. Now, when you look at this, you can tell me, teacher, I can actually bring these two and divide. So I will have 4x and differentiate y equals to 4x. But I just want to use the example to show you how this works. So just look at this. 2y equals to 8x. When I differentiate this, 8x, I will get a number, 8. When I differentiate 2y, I am supposed to get 2 and dy dx, the differentiation itself. So I will have dy dx here, because when I differentiate y, I get 1, just like when I differentiate x, I get 1. So 8, when I differentiate 8x, I get 8. I differentiate 2y, I get 2 dy dx. Now, for question like this, let's say if I increase it a bit more, when I differentiate 2y squared, it's just like I differentiate 8x squared. So how does it work? When I differentiate 8x squared, the 2 will multiply to the front, so it will be 8 times 2, 16, and index minus 1, so it's 2 minus 1. Same goes this side. When I have 2y squared, take the 2, multiply by the 2, so I get 4. Index minus 1, so 2 minus 1, I get y power of 1. Then because I'm differentiating implicitly, I'm differentiating a y, I will get dy dx at the side. So these are very not so good examples on how to differentiate, but I just want to put them side by side so that you can see how I differentiate a normal 8x squared and how I differentiate 2y squared. I just want you to see that. Okay, so don't bear with me. Okay. Now, let's go into deeper question. Let's say if I want to differentiate an equation y cubed plus 6x equals to x squared. When we differentiate implicitly, we actually differentiate every terms in the equation. Now, during exam, there's no need for you to write d over dx over all of them. This is just for you to understand what I'm doing here. So, I actually need to differentiate all of these terms. So, when I differentiate y cubed, it's just like I differentiate x cubed. So, the number, the index will come to the front. Then I will copy the y, just like I copy x. And then index minus 1. So I will get power of 2. Now, because I'm differentiating a y, beside these terms, I have to write dy dx. Okay, when I go to this one, there should be no problem. When I differentiate 6x, I get 6. I differentiate x squared, I will get 2x. Now, the question asks you for dy dx. So our next step will be trying to arrange this answer until we get only dy dx on the left hand side. So I will move the 6 over, and then I will bring 3y squared to the right hand side. So I will divide all by 3y squared. So that's my answer. Okay, so just bear in mind, every time when we differentiate a y, there is a dy dx beside it. Let's look at this question. I have 3x squared minus 2xy equals to y squared. When there are terms like this, we will consider them as multiplication of 2y and a 2x and a y, So I will treat my 2x as u and my y as v, just like I do the product rule. So when I differentiate du dx, I will get 2. When I differentiate dv dx, I'm supposed to get 1, but because I differentiate y, I have dy over dx here. Then I will apply this into a product rule. Now, this is what happened. Differentiate 3x squared, I get 6x, there's no problem. Minus, I still continue. Then I will follow the product rule. I will copy u, which is 2x. Then I differentiate my dv dx, which is dy dx. I will put it on that side. Plus v, which is y. That's where I put it. And du dx, which is 2. And I will write it there. The product rule is done. Then I will differentiate the last term, which is equals to y squared. Differentiating y squared, the index will come to the front. So I have 2y. Index minus 1, that's why my y is power of 1. But because I'm differentiating a y, beside it I have to write dy dx. Now, the next step will be trying to put all the dy dx on the left hand side and any terms without dy dx, for example 6x and 2y, to the right hand side. So I expand it first, putting in the negative, and I will try to push all the terms to dy dx terms to the left hand side. Okay, this is I will move this to the right hand side and move dy dx to the left hand side, if that makes sense. So I just want to write it properly. Okay, so 6 minus x, and this term I move it to the right hand side. So I move everything to the right, but I copy it in the left. Does that make sense? Hopefully that do. Okay, well, I just copy it so that it looks better, because I'm going to factorize dy dx out, because the question asks for dy dx. So I'm going to bring out dy dx. So after factorizing dy dx, the next thing that I'm going to do is I'm going to take 2x plus 2y and divide it with whatever on the right hand side. So I will divide both sides with 2x plus 2y. So I will end up something like this. Now once I'm here, I already get my dy dx. But there is still things to simplify. So I can simply just simplify this, factorize that out, and simplify it away. That is my answer. Okay. Now in this question number 3, I have a multiplication here, product of x and y there. So I'm going to do this very carefully. So 3 times 2, I get 6. Y, I copied it down. Index minus 1, that's why my y is to the power of 1. Because I'm differentiating a y, so I put dy dx beside it. Next, I write plus. This is 2y. When I differentiate 2y implicitly, I will get 2 times 1. But I don't write those 1. And when I differentiate a y, I get a dy dx. Now, here is the product rule. I copy u, which is x, differentiate v, which is my y, so I will get dy dx, plus copy y, which is y, so I just copy it down, differentiate x, I get 1, so there's nothing beside my y, okay? And then I will differentiate the last term, which is x cubed, so I will get 3x squared. Once that is done, my next step is to arrange all the dy dx on the left hand side and all the other terms on my right hand side. So it will look like this. Okay, from this part, what I need to do is I need to factorize dy dx out from there. Okay, once that is done, I'm going to divide both sides with 6y plus 2 plus x. So my answer will end up like this. Now, let's see. Is there anything else to factorize or to simplify? If no, then this is my answer. In question number 4, you will notice you have a quotient rule here. You will need the quotient rule to solve this. So I will do x over y. Later, you can take a piece of paper and set in y over x by yourself. So I will just do this one. So my u is x and my v is y. So differentiate du dx, I get 1. Differentiate dv dx, I have 1 here, but because I'm differentiating y, I have dy dx beside it. I'm going to put them into the quotient rule. Okay, so let's do this very carefully. So, quotient rule says we have to copy the v. So, for this case, the v is y. So, I will copy y. Differentiate du dx, which I get 1. So, I write there 1. Minus u. So, u is x. So, minus x. Multiply with dv dx, which is dy dx. So, I will write that there. Now, these steps will be the same for y over x. So I will need to follow the same step that I have here and do it into the put them into the quotient rule. Now, for this type of question, you actually do not need to separate the uv out at the side. After a few practice, I'm sure you will get a hang of this. Once you get this setting ready, it looks so big and scary. Don't worry, we are going to simplify it. Now, you can skip this step if you actually use 2x just now, but I just want to show you just by using the variables and the terms x and y, so I separate them out. So if you use 2x here, then all this will be inside already. Okay, so well, I just multiply it in and copy it down. So if you use 2x, then you will skip the step and you will get this answer over here. Now, the next thing that I'm going to do is I need to separate dy dx. But I cannot do that because this dy dx is separated by 2 fractions. So, I need to combine them first. So, I'm going to combine x squared multiply to the numerator on this side. And I'm going to take y squared and multiply with the numerator on this side. It will end up looking like this. Okay, so don't worry. Next thing that I'm going to do is I'm going to multiply x squared from both sides, and I will leave with this only. So what happened here is my x squared multiply in with 2y, x squared with this one, 2x squared dy dx, and minus, here's my minus, y squared multiplied by 3x, so 3xy squared, and the dy dx of course, and negative y squared multiplied with this one, I will get 3y cubed. Okay, everything put nicely. Once that is done, I need to find a way to transform all the dy dx one side and all the terms without dy dx on the other side. I'm going to do it again. So what is happening here is both of these, I move it on the right hand side, but I just copy it on this left hand side, so that I will make my job easier when I want to factorize and shift them. Alright, so I will factorize it out, and the rest is just copying. So I factorize this dy dx out, so my 2x cubed plus 3x y squared, I just copy it down, and of course this side are the terms without any dy dx. Okay, I'm going to divide this on both sides, and I will end up something like this, and I have to think whether this can be simplified or not. So when I look at the top portion, I notice I can still factorize y out. And when I look at the bottom, the denominator, I notice I can still factorize x out. Now, once I factorize that out, I notice 2x, the numerator and the denominator have something that I can clear away. So I will clear both of them, ending with my answer is only y over x. Okay, I'm done with this question. In question number 5, I have a composite function with an implicit function. So if any of you have not seen the differentiation of composite function video, I will leave the link in the description box below, and you can also check out the eye icon on top there. Now, when this appear in a composite function, we are going to do it like we do composite function, and of course we have to be very careful with the y. Okay, so how to do composite function? The index will come to the front like usual, and of course the behind here I will be taking dy dx and I will put in u just like just now, u equals to x, du dx equals to 1. The behind here is v equals to y squared, and when I differentiate dv dx, I will get 2y index minus 1, and then differentiate y, I get dy dx. And then I'm going to put them into the product rule later. Okay, so now let's settle the composite function. I have 7, index 7 comes to the front, copy the whole bracket, so I copy the whole thing down, and then index minus 1, so I have 7 minus 1, I get 6. Next thing is I need to differentiate all the terms inside the brackets. So I differentiate x squared, I get 2x. I differentiate 3y cubed, I will take 3 multiplied by 3, I get 9. Y cubed minus 1, so I have y power of 2. And because this is a y, so I need to write dy dx beside it. Now, equals to my product rule, copy u, differentiate v, that is what I have, I just copy down, plus, copy my v, which is y squared, and differentiate my u, which is 1. Okay. Now, after I've done all the rules properly done, I'm going to expand this. Don't get scared. Follow up. I have 7 and 2x. So 7 times 2, I got 14. And with the x there. Then, of course, this whole set, I will need to copy it here. Next thing is 7 times 9, I got 63. And I have my y squared, put there. Bring this whole bracket, multiply in, so I will copy the whole thing. And of course, my dy dx. Over here, I have 2xy multiplied by dy dx plus y squared. Now, I'm going to arrange the dy dx on the left hand side and all the other terms on the right hand side. So, just copy them properly down. So, all this here, 63y squared, and all this I will copy it down, plus my 2x times y dy dx. From positive, I will bring it so it will become minus 2xy dy dx. Equals to, I have my y squared here, and then in front there I have a terms without any dy dx. I will bring all of them and copy it down here. Once everything is done, then it's time to factorize out the dy dx, and I will just do all my copying all over again. Finally, I will bring them together. So whatever multiply with dy dx, I will make sure I divide it off. and I will divide on the both sides. So I will end up something like this, which I can no longer simplify. Then I will leave my answer as so. Okay. Now, implicit functions do come with trigonometry. So if you have not seen my differentiation of trigonometric functions, I will also link them down in the description box below, and can also check out the playlist that I will put in the icon here, somewhere here. Okay, so we need to differentiate sign, so I need the sign formula. Okay, differentiating sign, I will get cos x. Here again, I have a UV, so there's a product rule happening there. So we will be doing it straight away. Now, differentiate sine x, like usual, we will get cos x. Differentiate sine y is the same formula, we will get cos y. But because we are differentiating y, therefore I will get dy dx here. Then I will copy u, differentiate v, which is my y, dy over dx. Then I copy my y, the v, and then I differentiate u, which is 1, so I write that. That is the product rule. It's time to arrange. So I'm going to bring it all the dy dx on the left hand side and all the terms without the dy dx on the right hand side. Once that's done, the next thing, of course, is factorizing dy dx out. So I will put it there, pull it out, and I copy cos y minus x here. The next step, of course, is to get my dy dx. So I'm going to divide everything left and right with cos y minus x. So I will end up something like this. If I could no longer simplify it, then I will leave that as my answer. Okay? For question number 7, I have an exponent. So for exponent, I will need this formula. If you have not seen my differentiation of exponential function, I will give you the link in the description box below. Please check them out. Now, whenever we differentiate exponent, we will have to copy the whole thing. We differentiate, we copy the whole thing, and then we differentiate the power and put at the side. So for this case, I have implicit functions as a power there. So in previous question, we already noticed this is actually the product of x and y. So let's do this carefully. Differentiating exponent power of xy, I will need to copy the whole function in. Then I will differentiate the power and write at the side. So for this case is copy u, which is x, write it there. Differentiate v, dy dx, plus copy the v, which is y, and differentiate the u, which is 1. So I will put it there. Equals to differentiating x, I will get 1. I'm done differentiating. Now I need to arrange. So I will first multiply exponent power of xy into the equation. So I will get something like this. And then I'm going to move this one over. So I will have 1 minus y times exponent power of xy. And I will then divide everything with x exponent power of xy. That's all. For question number 8, I have ln x ln y equals to x plus y. So if you have not seen the differentiation of logarithmic functions, please check out the description box below. I will leave the link there. Now, for ln x, when I differentiate that, I will get 1 over x. So when I differentiate implicitly this equation, I will have 1 over x. And when I differentiate ln y, I will have 1 over y. Because I'm differentiating a y, I have to write dy dx beside it. Then equals to differentiating x, I get 1. Differentiating y, I have 1, but because it is a y, so I write dy dx. When this is done, I'm going to pull all the dy dx to the left-hand side and all the terms without dy dx on the right-hand side. So I will end up something like this. Once that is done, of course, it's time to factorize. So I will factorize the dy dx out, and what is left is a term like this. Now, this is a fraction. So I need to combine both these fractions before I can finish this question. So I will take y multiplied by 1. So it will end up like this. So y multiplied by negative 1. So I will get 1 minus y. And over this side, I take x multiplied by 1. So I have x minus 1 divided by x. Once that is done, I'm going to divide all this with 1 minus y over y. So left and right. So I will just bring it over, and it will become y over 1 minus y. When this is done, the last thing that I need to do will be just put them together. And if there's nothing else I can simplify, that will be my answer. Now, this is an equation when we have x cubed plus x and an inverse trigonometric function. If you have not seen that, please check out the differentiation of inverse trigonometric function in the description box below. Now, we have x to the power of 3 plus x multiplied with a inverse trigonometric function and an exponent. So for inverse trigonometric function, when I differentiate that, I will get 1 over 1 plus x squared if I have tangent inverse, the inverse of tangent. I differentiate that, I will get 1 plus x squared. That is a formula which is given inside your formula list. Now, differentiating x cubed, I will get 3x squared plus differentiating this set. Remember, I have x multiplied to tangent inverse y. So I have to do this by the product rule. So I copy x, differentiate inverse tangent y. I will use the formula. So I will write 1 over 1 plus y squared. But because I'm differentiating a y, then I have to write dy dx beside it. Followed by copy the v, which is tangent inverse y. Differentiating the x, I will get 1. Differentiating exponent, just now we mentioned before, we will copy the whole thing. And differentiating the index in the exponent, which is a y, I will get 1. And beside that, I have to add dy dx. That's why I have a dy dx here. Now, The next step will be, of course, arranging. So I will bring all the one with the dy dx to the left hand side and the one without dy dx on the right hand side. So I will copy it down here properly. And then finally, I will just need to factorize them out. Okay? And of course, after factorizing, I will need to bring the fraction together before I can move it to the right hand side, like this. Okay, you can straight away move it up. It's okay, no problem. You can save one step, but I just want to show you. I will need to divide it, and then I will bring the denominator up here. 1 plus y squared. Okay, which is from here, will go up and multiply. So, actually, to do this implicit function, you just need to remember every time you differentiate a y, you have to put dy dx beside it. Then you need to arrange and recopy and arrange again and recopy and simplify whichever terms that you can simplify. If you can't simplify, like for this case, don't touch it. That will be your answer. Okay? So that's, if you like the video, please give me a like, comment, share this with your friends so that everybody can score. And I will see you in the next lesson. In my next video coming up will be parametric differentiation. Subscribe to me so when the video is out, you will be notified. That's all. Thank you.